One of the things that was one of the most popular parts of our conversation last time, Robert, was there's a section where we talked about the different types of sugar and Diet Cokes and Coke Zeros and all these kinds of things.
Yeah.
You know, I can see a couple of cans on the desk over there where Jack is in the darkness that I can vaguely see. And these cans of fizzy drink, they all have some kind of sugar substitute.
Yep.
Are those sugar substitutes harmless?
No, of course not. A paper just came out like 3 days ago in Annals of Neurology, basically showing that non-nutritive sweetener consumption, so diet sweetener consumption, correlates with dementia. And we think we know why.
Why?
Reactive oxygen species, so oxygen radicals, little chemicals that are given off from various substances that cause changes in energy metabolism in cells and also cause damage in cells. ROSs, reactive oxygen species. The famous ones are aspartame and sucralose. Now, do monk fruit extract, do stevia, does allulose also cause reactive oxygen species? I very specifically looked for data on those, could not find it. But for aspartame and for sucralose, the two biggest ones that are available today, the ones that are used in a lot of diet drinks, huge amounts of ROS generation.
ROS?
So, reactive oxygen species generation. So anything that generates ROSs contributes to dementia.
Is the evidence strong at this stage?
Yeah, it's pretty darn strong. I'm actually giving a talk about this next week in San Diego.
I heard you've got a new theory on the causes of Alzheimer's dementia that's somewhat linked. This is it.
This is it. Yeah.
Can you explain that to me? And you've not talked about this publicly yet. You're set to talk about it in a couple of days, I hear.
Let me take it back a step. Okay. There's this organelle inside our brains called mitochondria. You've heard of mitochondria.
Yeah.
For your audience, mitochondria are the little energy burning factories inside each of our cells. What they do is they take food energy and turn it into the chemical energy that your cell can actually use to power itself. Okay? And that chemical energy has a name. It's called ATP. Now, if you took biology in high school, you've heard of ATP, adenosine triphosphate. The energy is in the phosphate bonds. So ATP will give up its energy and go to ADP, diphosphate, which will then give up its energy and go to AMP, monophosphate, which will then finally go to adenosine. And adenosine binds to the adenosine receptor and makes you go to sleep. Mm-hmm. By the way, that's where caffeine works. It blocks the adenosine receptor, keeping you awake so that the adenosine can't bind to the adenosine receptor. Okay? So that ATP is the currency of the cell. That's what makes the cell run. Anything that depletes ATP is going to put the cell at risk. Mm-hmm. Okay? Because it doesn't have the energy it needs to run.
Yeah, it's gasoline.
It's like gasoline. So what happens when you start running out of gasoline? Well,
you break down.
You'll break down. So brain fog, difficulty concentrating, irritability, and ultimately all the way to depression. So the amount of ATP within any given neuron is the proximate cause of neuronal dysfunction that we see as neurocognitive and neurobehavioral change. Now, how do mitochondria and how do ROSs fit into this? Mitochondria make ATP, but every time they make ATP, they also make ROSs. There are 11 steps in mitochondria, and they all give off ROSs. Now, those ROSs are going to damage the cell. They have to be gotten rid of. They're like toxic fumes. They got to be gotten rid of. And so we have a pathway in each cell of our body to get rid of the toxic ROSs. Okay? They're called antioxidants, like glutathione, vitamin E, vitamin C, a host of other flavonoids. Okay, those basically quench those reactive oxygen species, they go to die. If you do that, then the ROSs basically just get funneled away and all is well and the cell can keep working. But if for some reason those antioxidants aren't up to par, if, for instance, you've been eating ultra-processed food and you can't make your antioxidant complement, then the ROSs feed back. And what happens is the ROSs are basically telling the cell, hey, you're shunting too much energy down this pathway because I can't clear them. So there's too much stuff. So shut it down. And so what happens is that instead of funneling the glucose into the mitochondria to generate more ATP, it diverts it and it goes off into other directions like glycogen, which is in the brain is not good, or fat, which is even worse. And bottom line, your cell is now not energy producing like it used to be. It has now been reduced in terms of its energy capacity. What's that going to do? That's going to reduce ATP generation. Okay, that's step one. Now step two. There's this stuff called cortisol. Cortisol comes from stress. Cortisol comes from sleep deprivation. Cortisol comes from exogenous glucocorticoids, like steroids being given to people for, autoimmune disease or for, other illnesses. Okay, that cortisol causes neurons to increase in metabolism, causes them to burn energy faster. Okay, so now you have an increased ATP utilization. So you have a decreased ATP generation. Now you have an increased ATP utilization. Now you've got an energy crisis inside each cell. Now your ATP can't keep up with the needs of the cell. And when that happens, now you've got symptoms, whether it's brain fog or irritability or all the way to frank depression. Okay, now, step three. There are these proteins inside each neuron called amyloid precursor peptide, APP. Okay, it's a normal protein in all cells. Every cell in your body has APP. It needs to stay in solution. And in order for it to stay in solution, energy has to be applied to it in order to keep it in solution. The minute the ATP in the cell goes down, they come out of solution and they start forming aggregates, which we call plaques.
Yeah.
Okay? And those plaques damage the cell, which then start an inflammatory process in the cells next door called the microglia in order to clean up the process. And now you've got plaques and an inflammation, and now you've got neuronal cell death. That's dementia. So it starts with an ATP energy crisis, moves through plaque and inflammation to generate neuronal cell death. Well, this is problematic to say the least. And by the way, anything that generates ROSs has been associated with Alzheimer's. Anything that increases ATP utilization, like stress, glucocorticoids, fever, autoimmune disease, also increases Alzheimer's. So anything that increases step one, anything that increases step two, ultimately leads to increased step three and Alzheimer's.
So to simplify this in a couple of sentences for someone that has no scientific understanding, and we're going to have to cut a few corners here scientifically in order for them to have a framework to understand it. How would you give me some sort of an analogy for it? Maybe in the context of, I guess, a petrol station and a car.
Yeah. So, I mean, if we're basically doing petrol, we're talking energy only.
Yeah.
Okay. So bottom line, your car runs on petrol. Mm-hmm. Okay. The petrol comes in, that's the glucose, and the engine, okay, powers pistons, and the pistons then power an axle, and the axle then powers wheels, and you go.
Yeah.
Okay. But there are a lot of things that have to go right for all of those things to happen. Like, for instance, your energy, the gasoline, has to get into the engine in the first place. What if you have carbon deposits on your intake manifolds? And if you have a problem with any one of those steps, you're going to end up with a jalopy instead of a sports car.
I mean, that's what we're seeing in the United States. Over 7 million Americans live with Alzheimer's, and this is expected to double to almost 13 million in the coming decades.
Indeed. Because we haven't solved the problem.
That's the mechanism. What is the cause?
Right. So we know that the cause is environmental. Now, people say, oh, Alzheimer's is genetic. Garbage. There is a genetic component to Alzheimer's. I'm not arguing that. There is. Okay? This is this thing called ApoE4. And if you have 2 copies of ApoE4 on your genome, your risk for getting Alzheimer's is 9 times the general population. That is absolutely true. I don't disagree with that. So ApoE4 is not a good thing. I'm not arguing that. Once upon a time in evolution, having 2 copies of ApoE4 was good because it meant you got fat up to your brain pretty fast. But we don't need that right now. That's kind of an old news kind of issue. People who have double doses of ApoE4 are at higher risk. There is absolutely no question about that. But they can mitigate that risk if they change their diet. Okay? They can eat a very low-fat diet and improve their risk down to the general population. Okay? Everything else in Alzheimer's is not genetic. By the way, that genetic component is only 5% of all Alzheimer's. So that means 95% of Alzheimer's risk is environmental. Now the question is, what in the environment? Well, air pollution, ionizing radiation, microplastics. Okay? There's nothing you can do about any one of those 3. That's baked into the cake. You can't do anything about those today. What other things? Sleep disordered breathing, medications, ultra-processed food. Okay, what about ultra-processed food? Fructose, my favorite, hobby horse, the sweet molecule in sugar. Low omega-3s, so no, fish, eggs, chicken. Lack of fiber, because fiber suppresses inflammation. Presence of emulsifiers. Okay. B vitamins, lack of B vitamins, particularly B6, B12, folate. Okay. Those things are all associated with an increase in reactive oxygen species. You can manage those, you can mitigate those, thereby increasing mitochondrial function, increasing ATP generation, and preventing that cellular energy crisis so that you don't end up behind the 8 ball and you don't lose your neurons.
When people tell me that Alzheimer's is associated with having a sort of energy crisis in the brain, I'm increasingly hearing people talk about ketones. It's remarkable the improvement in cognitive performance that I feel when I'm fasted or I'm in a ketogenic diet. Whereas if I've been eating a lot of carbohydrates or sugar, it's like my brain is like backfiring.
Fog.
Yeah, it's like
fog.
Stumbling over itself.
I'm not surprised. The food industry tells you, well, carbohydrates are energy. Actually, that's not true. Carbohydrates inhibit energy production.
How do you mean?
So there's this thing called a bomb calorimeter, and there's this thing called a mitochondria. They're not the same. A bomb calorimeter, you throw food into the bomb calorimeter, it explodes and it gives off heat. Okay, there's, captures the heat, measures the heat. And that's how we know, for instance, fat burns at 9 calories per gram, protein burns at 4 calories per gram, carbohydrate burns at 4 calories per gram, which is why fat is more energy dense than protein or carbohydrate, which is how we all determine that fat made you fat.
And the bomb calorimeter is also how they determine if a bag of crisps or chips, or whatever you call it here, is 200 calories, because if you put them in there,
exactly,
it will release 200 calories of energy.
Right, because a calorie is that amount of energy that raises 1 gram of water 1 degree centigrade.
Okay.
So it is a measure of physics.
Okay. So
it's a measure of heat generation.
Okay.
Okay. Mitochondria are not bomb calorimeters. They are not capturing heat. They are giving off heat. They are capturing ATP. No bomb calorimeter captures ATP. Mitochondria capture and generate ATP. Mm-hmm. Now, turns out 35 to 40% of what mitochondria generate turns out to be heat. That's why you have a body temperature. Mm-hmm. It's from that. And so you will never have a 100% energy efficient mitochondrion, because if you did, okay, you would have a body temperature of, room temperature, okay, and you'd be dead. That's not the way it works. Bottom line, that transfer of food energy to chemical energy loses energy in the process. Okay, the bomb calorimeter can't tell the difference, but your mitochondria can. Ultimately, it's how efficient are your mitochondria at converting food energy to ATP. The bomb calorimeter can't tell you anything about that. So these two phenomena, the concept of calories as fuel and the concept of calories as generators of ATP, have really very little to do with each other. And it turns out that there are individual things in food. The famous one is fructose, but there are others, lectins and others, that actually inhibit the mitochondrial generation of ATP. So they actually inhibit your ability to turn food energy into chemical energy. If that's the case, even if they have calories per gram in a bomb calorimeter, if they're interfering with mitochondrial function, are they food? What is the definition of food? Substrate that contributes either to growth or burning of an organism. Well, I just told you, fructose actually inhibits burning. Turns out, fructose also inhibits growth. It inhibits cortical bone growth, trabecular bone growth, cancellous bone growth. Bottom line, people who eat ultra-processed food end up shorter. We have the data for that. So, if a substrate that passes your lips does not contribute to growth and does not contribute to burning, is it a food?
I guess not.
I guess not.
What is it then?
It's a poison.
And how much of our diet do you think is poison?
A fair amount. Ultra-processed food is loaded with them. Real food is not loaded with them. You can still find them, but not loaded with them. Ultra-processed food has, in my opinion, 5 things wrong with it. Too much sugar, which poisons your mitochondria. Not enough fiber, which is necessary to suppress inflammation. Not enough omega-3 fatty acids, which are necessary to build your brain and conduct neurotransmission. Too many emulsifiers, which leads to gut inflammation and therefore systemic inflammation. And then we can throw on top of that the food dyes and food additives, which are mutagenic because they're petroleum-based. That's ultra-processed food. Ultra-processed food has been associated with every single one of these diseases, including every single mental health disease, especially dementia, as we now have seen. Ultra-processed food is specifically associated with dementia, and even diet sweeteners are associated with dementia through this reactive oxygen species pathway.
The sugar industry can't be your biggest fan.
They're not. I'm trying to help them, though. I am trying to help them. Last year, not too long after we had our previous session, I was the keynote speaker at the 4th International Sugar Reduction Summit in Atlanta, Georgia. Daniel in the lion's den. And, why would they invite me? I am, I'm their conscience. I told them, I said, I don't want to be your enemy. I want to be your conscience. I want you to do the right thing. Okay. Ultimately, look, Ultra-processed food's not going away. As much as I would like it to, it's not going to go away. And I'm not even sure we want it to go away because we've got to feed 10 billion people by the year 2050, and we're not going to have enough land and ocean to do it. Ultimately, ultra-processed food is here to stay. It is baked into the cake. But the question is, can we make ultra-processed food healthy? Right now, they're not. Right now, what's going on in the U.S., food industry is doing the exact opposite. It's making food disastrously disease-producing. The question is, could you change that? And the answer is, yes, you can. In fact, we've done it. We have been doing it. 5 years ago, I started working with an offshore food company. Gratis, by the way, no money changed hands. And so they came to me and they said, look, we know we're part of the problem. We want to be part of the solution. We know that Kuwait has an 18% diabetes rate and an 80% obesity rate. And we don't want to be the reason. We want to be the help. Can you help us figure out how to make metabolically healthy processed food? So I convened a scientific advisory team of 5 members, and we worked for the next 3 years, looked at every single process, every procedure, every vendor, every ingredient, every product, sent them all for biochemical analysis to figure out what's going into the food, what's coming out of the food, is the food metabolically healthy, what has to be done, how does it need to be re-engineered to lead to something that is metabolically healthy. And we came up with a set of principles, which we published in Frontiers in Nutrition in 2023. And we call it the metabolic matrix. And we basically collapsed it down to 9 words. 3 clauses, 9 words. Protect the liver, feed the gut, support the brain. That's it. Those 3 things. Anything that passes your lips, that protects the liver, feeds the gut, supports the brain, is healthy, whether it's ultra-processed or not. Anything that passes your lips that does none of the 3 is poison, whether it's ultra-processed or not. So it's actually not the ultra-processing, it's whether or not it contributes to metabolic health. So then we started re-engineering products in the KDD line, and they have 180 items in their portfolio. We have re-engineered 10% of them, 18 products, to become metabolically healthy. And we have tested them on people in Kuwait to demonstrate their metabolic benefit. And they are on the shelves now.